Welcome to the lecture. Today we are going to see the problems on bus admittance matrix using direct inspection method. Let us see the example. For the given network, form the bus admittance matrix using direct inspection method. So here they have given the 4-bus system. In that they have given the admittance values of each line. So here for each line they have indicated with the negative values of the reactance, so that from the data itself we can identify that the given value is admittance. So line 1 to 2 they have given the admittance as minus j 0.5, line 2 to 3 minus j 0.6, 1 to 3 minus j 0.4, 1 to 4 minus j 0.4, and 3 to 4 minus j 0.5. Now for this given network, we have to form the bus admittance matrix using direct inspection method. So totally we are having 4 buses. So we will have a 4 cross 4 matrix. Now first we will form the diagonal elements. Diagonal elements y11. So for the diagonal elements, we have to consider all the lines connected at bus number 1. So at bus number 1, there are 3 lines are connected. That is line 1 to 2, 1 to 3, 1 to 4. So we can write y12 plus y13 plus y14. So all the given values are line admittances. So directly we can add minus j 0.5 minus j 0.4 minus j 0.4. So if you add all these elements, we will get y11 is equal to minus j 1.3 minus j 1.3. Similarly, we have to calculate for y22. So line connected at bus number 2 is, there are 2 lines are connected, that is y21 plus y23. So the admittance value is y for y21, that is j 0.5 minus j 0.6. If you add these elements, we will get y22 equal to minus j 1.1. We have to calculate for y33. The line connected at bus number 3 is, that is y32 plus y31 plus y34. The admittance value for line 32 is minus j 0.6. Similarly for y31 is minus j 0.4 and y34 is minus j 0.5. If you add these elements, we will get y33 equal to minus j 1.5. Similarly, for y44 equal to the line connected at bus number 4, that is 2 lines are connected, y41 and y43. So y44 equal to small y41 plus small y43. The admittance value of line 4 to 1 is minus j 0.4. Similarly for line 4 to 3 is minus j 0.5. So y44 is equal to minus j 0.9. Now we have determined all the self admittance values. Now we have to determine off diagonal elements. Off diagonal elements. y12. y12 equal to minus small y12. The admittance value of line 1 2 is, they have given us minus j 0.5. So minus of minus j 0.5. So you will get y12 equal to j 0.5. That will be equal to y21 because bus admittance matrix is a symmetric matrix. Similarly, y13. y13 equal to minus small y13, it is minus y13 value is minus j 0.4, minus j 0.4. So y13 equal to j 0.4, that will be equal to y31. Similarly, for y14 equal to minus small y14, that will be equal to minus of the line connected at bus number 1 to 4 is minus j 0.4, j 0.4. So y14 equal to j 0.4, that will be equal to y41. Now we have to calculate y23. y23 is equal to minus small y23, that will be equal to minus of y23 value is minus j 0.6. So y23 equal to j 0.6, that will be equal to y32. Similarly, y24. y24 equal to, there is no line connected between the bus 2 and 4, so that y24 become 0. Similarly, that will be equal to y42. Now we have to determine, we have already determined y31, y32. Now we have to determine y34. y34 equal to minus small y34, that is minus of the line admittance value of y34 is minus j 0.5. So y34 equal to j 0.5, that will be equal to y43. Now we have determined all the elements of bus admittance matrix. At last we have to write the y bus matrix. So y bus equal to y11, y12, y13, y14, y21, y22, y23, y24, y31, y32, y33, y34, y41, y42, y43, y44. By substituting all the elements here, we can form the bus admittance matrix. So y11 is minus j 1.3. y12 is j 0.5, that will be equal to y21. Similarly, y13 is equal to j 0.4, that will be equal to y31. y14 is j 0.4, then similarly that will be equal to y41. So y22 is minus j 1.1, y23 is j 0.6. So same we can write it for y32. Then y24 is 0. Similarly y42 is 0. y33 minus j 1.5, y34 is j 0.5, y43 is j 0.5. That last y44 is j 0.9. So this is the